and beyond. Space, in partnership with the European Space Agency.
For centuries, astronomers have chased comets across the skies, looking for clues as to the origins of our solar system. Swift and bright, they are an enchanting sight.
They're beautiful, transient, some of them faithful. They come back to see us from time to time.
Tugged from deep space by the gravity of the sun, comets shed dust and gas as they warm, revealing some of their secrets within.
A comet is a piece of rock and ice mixed together, roughly to imagine something like Mont Blanc or one of the largest mountains in the Alps. That is the typical size of a comet.
And these comets could tell us something rather profound about ourselves.
Comets are interesting for a lot of reasons, and one reason where we're really looking, and it's the most fascinating area, is have comets played a role to bring life on Earth?
To find out more, we set out on a comet-chasing road trip around Europe. First stop is near Jena in Germany. It's a few hours before dawn, and scientists here are trying to glimpse the embers of Comet Ison.
Good morning, folks. This is 6 o'clock in the morning, and we are at the Thüringer Landessternwarte in the middle of Germany. We operate a 2-meter optical telescope, and today we want to have a possibly last look at the Comet Ison.
Ison appeared to disintegrate as it flew around the sun in late November, but parts of its core could remain. The only way to find out is to have a look.
Some stars are for focus, right? It's in a focus.
Everybody was wondering what happened with the comet, and so now we hope to have the opportunity to get an answer.
Our next stop on the Comet road trip is Switzerland. Here, researchers are doing something rather unusual.
So, now we're going to go down into the labs downstairs. We're going to make ourselves a comet.
There are thought to be 1 trillion comets out beyond Pluto. They're not all the same, but they do share similar ingredients of water ice, frozen gases and dust. It's quite a simple recipe.
First of all, we need to create a sort of a liquid, and so we're mixing our 50% of our comet, that is this water ice, we're mixing it now with a little bit of liquid nitrogen, and we're using here carbon black. It's finely divided carbon particles. And now we do some comet cooking. Well, the liquid nitrogen is currently sitting at around minus 200 degrees centigrade, and that's keeping the water ice from evaporating and keeping it from sticking together. What we now do is that we tip the mixture into a sort of a mold, and that is a fake comet, ready for experimental studies.
Back at the observatory, and what should remain of Comet Ison should be in the sights of the telescope.
These are the images which are coming in, but it looks like the sky is still not very good close to the horizon. We will go for another few minutes because it's already 7:15 in the morning. Then we have to see whether we can find a trace in the data, but right now it doesn't look that promising.
Once more onto the Autobahn, destination Darmstadt. This is the European Space Operations Centre, home to the world's most ambitious comet-chasing mission, known as Rosetta. The control room is quiet for the moment as the Rosetta satellite sleeps in deep space. But in 2014, this ESA probe will do something quite extraordinary: catch up with a comet, fly alongside, and put a lander on its surface.
There are great hopes in the science community for the results from Rosetta. We don't know what a comet feels like. Is it like very pulvery snow that you go when you go skiing? Is it something like hard, which is just snow that has been sitting on the side of the road for a couple of weeks at minus 20 degrees and it's really hard? That we don't know. We have an idea how a comet works, but the details are missing. And that we can study with Rosetta. With the instruments we are putting there, they are really very sophisticated. We will get really in detail the molecular composition. We know which elements are there. We will measure the isotopic ratios. And that gives us a lot of information about the evolution history of that comet.
At the University of Bern, the fake comet is under scrutiny. The experiments here are all linked to Rosetta because the scientists use their readings to better interpret the data they'll get from the mission.
Comets are thought to be sort of relics from the formation of the solar system. And so what we're looking at is something that has been just in deep freeze storage for us, waiting for us to take a look at for 4.5 billion years. So we're taking this particular sample and we're going to test it, put it and simulate as if it were in space. The main reason for putting the sample into vacuum is that water ice sublimes in vacuum, of course. When it's doing that, then the surface evolves. It becomes richer in the non-volatile material, richer in this carbon material in our simulation. And we look to see how that actually happens. Does the water sublime from slightly below the surface and pop out? Or does it really just sublime from the surface, and does the surface then slowly recede with time?
At the observatory, dawn is breaking. Just a few minutes remain to take images before the sky gets too bright.
We hunt for the comet, or for the remains of the comet. Yeah, I mean that was pretty clear from the very beginning. I think you agree, Hermann, that given those say conditions, it will be extremely difficult, right?
Take data, regardless what it is. Take data, because you can always, if you don't have the data, you can't do anything. And don't think for the moment, just take them as they come.
Ground-based observations often give great detail, but the biggest leap forward in comet science has come with space missions. One of the first major landmarks was in 1986, when ESA's Giotto mission sent back these close-up pictures of Halley's Comet. It showed a dark, ancient nucleus billions of years old. Then, in 2006, NASA's Stardust mission flew right through a comet's tail and brought a sample of dust back to Earth. Inside that sample, the scientists found something rather curious.
The dust was analyzed in laboratories here, and they found, of course, interesting minerals there, but the most interesting thing I think they found was glycine. Glycine is an amino acid which is used in the DNA of life on Earth. It's one of the 4 basic amino acids used in our DNA.
Scientists were intrigued to find amino acids in comet dust, and they had new questions too.
Life on Earth uses a specific type of amino acids, the so-called left-handed amino acids. In nature, they, in principle, or chemistry can produce left and right-handed one, but life uses only the left-handed one, and we want to understand why so. It's not known, and we want to understand also whether the amino acids in comets are left or right-handed, because if we find only left-handed, this is the next hint that maybe life really, or the ingredients of life were brought from extraterrestrial space to Earth.
As the comet-chasing road trip ends, it's important not to draw hasty conclusions.
We will not find life on a comet. We might find ingredients that will lead to the evolution of life.
Rosetta could help us solve so many riddles, not only about the origins of life, but also the question of whether water on Earth was brought here by comets.
That's the big revolution, that we're going to get close to comets and now land on one. And if everything goes well, it'll be an enchanting spectacle for several months, revealing at close quarters what a comet is really like.
It seems a whole new comet hunt is underway.